Hello, we're Team 24091. I'm Adrian.
Hi, I'm Hannah.
Hi, my name is Kent.
Hi, my name's Peyton. This is our project From Experiment to Experience for Synthetic Ivory.
The objective of our project is to develop and design a production process for synthetic ivory using resins and calcium compounds, replicating the material characteristics of ivory. A small introduction and some background information is that ivory is a material composed of dentin found on animals such as elephants, rhinos, and walruses. Ivory is used to make decorations, jewelry, piano keys, and chess sets. Elephants are estimated to go extinct by 2040 as 100 elephants are poached each day. The annual illegal ivory trade industry makes $23 billion. Proposed solution for making synthetic ivory is to develop a production process to create synthetic ivory using the optimal resin and calcium compounds. To achieve the optimal faux ivory, prototypes will undergo testing of color analysis, hardness, tensile strength, and density.
The materials used to carry out this experiment consist of resin, to act as a binding component, and calcium minerals, to aid in achieving an optimal color hue and aid with the material characteristics such as density or hardness. The three resins to be tested are epoxy, polyurethane, and acrylic resin, while the calcium minerals to be tested are calcium carbonate and calcium phosphate, making a total of 6 possible combinations to analyze to determine which best resembles ivory.
In this video, we used the epoxy resin and calcium phosphate for the demonstration. Weighed out the calcium phosphate. For this sample, we used about 3 grams. Then weigh out about 20 grams of resin with the required amount of hardener. Mix the resin and hardener for 2 minutes and weighed out about 5 grams of the mixture. Then we add the calcium phosphate and mix for another 2 minutes. Here is our final mixture. Then we transfer the mixture to the silicone mold for the tensile strength test. The sample cures after 6 hours.
The most important characteristic was color. We originally wanted to qualitatively check the color for similarity using paint swatches, but we decided to quantify the color comparison for more precision. To do this, we used colors' RGB values as points on a 3D space and calculated the distance between each color using Excel and Python. We compared our paint swatches to standard ivory and then our ideal paint swatch to our samples. And the optimal samples in our initial testing were the polyurethane and calcium phosphate mixtures with a 1-to-1 mass ratio. We also collected data on the tensile strengths of our samples, which measures how much stress it can handle before breaking and would be its general strength. We used the ASTM standard D63822 and had to shape our material into this Type 4 sample. Simple 3D printed molds proved to be difficult to remove our cure product, so we made silicone rubber molds using a 3D printed template to get our samples in the desired shape. Our data for the test showed that pure resin samples have a higher tensile strength, and adding calcium makes it weaker. Our best sample was pure epoxy resin, which produced a tensile strength of 53.3 megapascals, while ivory has a tensile strength of around 120 megapascals. Data on Young's modulus was also collected with the tensile test. Young's modulus measures the resistance of the material to stretching and deforming. It's a measure of elasticity. Our data showed that epoxy resin samples were better, and adding calcium increased the Young's modulus. The best sample was epoxy resin and calcium carbonate with a 1-to-1 mass ratio, which produced 2.67 gigapascals. Meanwhile, ivory's Young modulus is 12.5 gigapascals.
The team determined to use a Shorty hardness tester to measure the hardness values of the ivory samples. Real ivory has a Shorty hardness value of 90. The epoxy resin did the best at approaching this desired hardness with both 1-to-1 mass ratios of calcium carbonate and calcium phosphate approaching a hardness value of 85. To measure the density of the samples, first the weight of each sample was recorded. Then the samples were placed in a graduated cylinder filled with water, and the volume displacement of the water was measured. The density was calculated by dividing the mass by this volume displacement. The epoxy and calcium phosphate mixture produced the optimal density trend, aiming to achieve a density of 1.8 grams per centimeters cubed.
So next is the scaling up portion of our presentation. We designed a scaled up process for our optimal product, which was epoxy resin and calcium phosphate. Epoxy resin and the hardener catalyst will be added to a jacketed mixer/reactor in their proper ratio of approximately 3-to-1 by volume. The calcium will be added by a conveyor belt with its ideal ratio. The product will then be removed from the reactor via a pump to a conveyor belt of rectangular 1.5 liter molds, which will be set aside to cure. Complete curing would take at least 15 hours. The jacket of the reactor cycles and condenses water to maintain a low temperature and prevent curing within the reactor. The cleaning process will be done every day at the end of the shift by pressurizing acetone into a rotary spray ball via a pump. This would clean the mixer of excess residue and the product flow line.
Piano keys, chess sets, and jewelry were historically made using ivory. By determining the number of these goods sold annually and calculating the volume of supposed ivory needed to construct these items, it was determined that 1,400,000 liters a year are needed for the current market. The goal of our scaled-up process is to capture 2% of this market, resulting in the production of 800 liters of synthetic ivory daily. It was assumed that the scaled-up process would operate as a semi-batch process over an 8-hour period for 5 days a week. It was estimated that the total annual cost for the scaled-up process were $7,200,000. This cost is primarily due to the raw materials, totaling around 75% of the annual costs. Selling the synthetic ivory at $32.34 a pound generates a profit of $12.50, a rate of return of 20%, and a resulting net present value of $5,100,000.
For safety, epoxy resin has a curing process that is an exothermic reaction which releases heat in a short amount of time. The temperature of a scaled-up reactor must be managed with the heat exchanger to prevent a runaway reaction and an explosion from occurring. When storing calcium phosphate, it must be kept away from water or moist air. To mitigate this exposure, the humidity will be monitored and controlled, especially during storms or monsoons. Acetone will be used to clean the resin out of the equipment in the scaled-up process. Acetone is very flammable and should be kept away from an open flame. The epoxy, acetone, and calcium phosphate will all be discarded as waste. For plant safety, one will be in an enclosed space, and oxygen shortages, vapor releases, and other physical dangers. When cleaning and working on maintenance, a lockout tiger procedure will be followed. To control high pressures and temperatures, suitable pumps and safety features such as pressure gauges and relief valves will be installed. The environmental impact of resins is that resins are very flammable and toxic. Neighboring communities and companies for the scaled-up process will not be affected by resin fumes, as the building will be well ventilated. An HVAC system that uses filtration will be installed. The filter will be disposed of every month. Calcium phosphate is a rock that is composed of lime and sand. Mining of the natural rock causes disturbances in the environment, such as changes in the ecosystem destruction, dust emissions, and higher noise level. The social impact of real ivory is what makes integrating synthetic ivory into the economy and society so difficult. People desire the genuine thing, and changing beliefs takes time. Because of the social status, it will be hard to convince or stop people from purchasing real ivory. Synthetic ivory may not change their beliefs.
In conclusion, the optimal combination was epoxy resin mixed with calcium phosphate with a 1:0.75 mass ratio. This mixture resulted in the closest sample to resemble the material characteristics of ivory, such as tensile strength, hardness, and density. Selling resin at $32.34 a pound generates $19.84 in profit, a rate of return of 20%, and a net present value of $5.1 million. Further studies that could be implemented into our project include further experimentation to optimize the calcium phosphate and epoxy ratios, determining the heat of reaction for epoxy resins, searching if there is a biodegradable resin alternative for our synthetic ivory, and determining if acetone can be recycled for the cleaning process. Thank you so much for showing interest in our project From Experiment to Experience Synthetic Ivory. We're Team 24091, and we hope to see you at Design Day.